Looking at sine and cosine functions, we need to be able to take the derivative of those as well. So we need to remember a couple of trig identities. Not that you're going to have to memorize these for the AP test or anything, but if I have a cosine of a sum, that's the same as cosine of A cosine B minus sine A sine B. For the sum of sine, it would be sine A cosine B plus cosine A sine B. We also want to remember that the limit as h approaches 0 of sine h over h is 1, and the limit as h approaches 0 of 1 minus cosine of h over h is 0. Very important. So let's start with sine. So if I use my limit definition of the derivative, we're going to take the limit as h approaches 0 of f of x plus h, so that would be sine of x plus h, minus f of x, so minus sine x, over h. So let's apply this sine identity. The limit as h approaches 0 of, so this is going to be, so x plus h. Okay, so sine x cosine h plus cosine x sine h minus sine x all over h. Now notice that these two terms, here and here, both have a sign, right? So if I separate those out, I'll have the limit as h approaches 0 of, if I factor out a sine out of those, I'm going to have sine x and then cosine h minus 1. Let's go ahead and split it up too and make that another fraction, so plus cosine x sine h over h. Remember, when we split it up like that, then we can take the limit of each of those as h goes to 0. Now I want you to notice something. Some of this should look really, really familiar. As h approaches 0, that's going to go to 0. And as h approaches 0 on this one, it's going to go to 1. So I'd end up with sine x times 0 plus cosine x times 1 which is just going to be a 0 plus cosine x, which leaves me with cosine x. So the derivative of sine is cosine. Now let's look at cosine. So if I take cosine and do my limit definition of the derivative, I'm going to have the limit as h approaches 0 of f of x plus h, so cosine of x plus h minus the cosine of x all over h. Well, I'm going to use this trig identity and get cosine x cosine h minus sine x sine h minus cosine x all over h. I wonder if we can do something similar to what we just did. I notice I've got two terms with cosine in it. This one, it's got a cosine x, and this has got a cosine x. So I'm going to do a similar technique and factor out the cosine x from each of those terms. So I have cosine x. When I factor it out of that term, I still have cosine h. That looks like cosh. Minus 1. And then I'll go ahead and make that another fraction. It'll be sine x sine h over h. Oh, look at that. This is going to look good. So I'm going to separate out into two limits. Minus the limit as h approaches 0 of sine x sine h over h. Now when we let h go to 0, this goes to 0, this goes to 1. So when I let h go to 0, I'm left with cosine x times 0 minus sine x times 1. Anything times 0 is 0. That's minus sine x. So I get a negative sine x. So that is the proof of our trig identities.